So I can consider a complex scalar field theory defined in terms of two fields, phi and phi star, which are independent fields, and I introduce two sets of annihilation and creation operators. I call them, let us say, A and B. So A and A dagger, B and B dagger. However, I can equivalently rewrite my theory of complex scalar field in terms of two real scalar fields, phi 1 and phi 2. And then, so it would be analogous to a double oscillator. And then I can introduce two sets of annihilation and creation operators again. I call them A1 dagger and A2 dagger. I can, of course, correlate my creation and annihilation operators A dagger, B dagger with A1 dagger, A2 dagger appropriately. Okay. So the idea is that we are going to handle with two sets of annihilation and creation operators. And now you would be able to see why we are advocating this particular idea, because in our theory, x mu, this is a function of tau and sigma, or this is a function of equivalently in terms of sigma plus sigma minus. Here sigma plus sigma minus, I sigma 0 plus minus sigma 1, or this is equal to tau plus minus sigma. Now this x mu I can you see, this is now the situation becomes a little more clear, that we have x mu, which is expressed as a sum of two x mu of L, x mu of R. One of them is purely a function of sigma plus, and the other one is purely a function of sigma minus. So they are two completely independent modes. Okay, and therefore, if I like to make a Fourier expansion of this and a Fourier expansion of this, here I would need one set of annihilation and creation operators, and here also I would need one set of annihilation and creation operators, and the two have to be independent. Initially, both of them are independent. If they get related, that is to our advantage. Okay, if they can somehow be related to each other as a consequence of few things, that we will see case by case. Okay, so in general, I would introduce some alpha mu k. So dagger or star. So I would have this and this. This is one set, and this is. So this is one set of annihilation and creation operators, and this is another independent set of annihilation and creation operators. And if this guy gets related to this, or these guys get related to this, we will see case by case. Okay, we will consider different cases in open string and closed string theory with different boundary conditions and so on. So this is our scheme. That is what we want to learn. Okay. And for this reason, and actually the basic physics that we learn from harmonic oscillator, for example, in quantum mechanics, it applies exactly to field theory and it applies exactly analogously to string theory. Therefore, we need to connect everything and understand, try to look at it in a very elementary manner. That's the whole purpose. All right. So now I think with that we have defined our scheme, and now I think we could proceed reasonably well. Okay. So uh, and so here we have this sigma plus minus h star plus minus sigma, and so you can invert this, and sigma plus, no, this is okay, sigma plus minus is okay. So we only need to see in the instant form dynamics, we had the metric eta mu nu, it was defined by this. However, with light front coordinates, this became 0 minus 1 half 0, and therefore this was 0 minus 2 minus 0, and our we had already seen that Ps square, which was minus d tau square plus d sigma square in the instant form coordinates, was equal to minus of d sigma plus times d sigma minus, and the measure d2 sigma, which is d tau d sigma, this turns out to be minus 1 half into d sigma plus d sigma minus. Yes, that's correct. So that is essentially everything that we have done, and by this we can then write down our action. S, this is minus p by 2 d2 sigma square root of minus h alpha beta g alpha beta. Now h is your minus square root of minus h is square root of minus, this is 0 minus 1 by 4 and minus 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 1 into minus 1 by 4, and this is equal to 1 half. So we know this object, and then our h alpha beta, g alpha beta is h dot g. This we can calculate separately. Let me just write down the result here. This is minus 4 times del plus x mu del minus x. Okay, so this means once we know this, so we can write down our entire action in terms of at the moment I am just using this value here, and then we can, for the sake of completion, so this is minus t by 2 d2 sigma, our integration measure. This is minus 1/2 d sigma plus d sigma minus, then this square root, this gives me a factor of 1/2 times h dot g, for which we can substitute this value, and this would then be, this is minus h dot g, or let me h dot g I will calculate a little bit later. So but let me just use this value here. So minus plus 1/2 and 4 here, so this also goes away, so minus t by 2 would stay here, and integral d sigma plus d sigma minus and del plus x mu and del minus, no, this is, I think this